These identities are called the sum and difference identities. And if I would have just showed you these formulas to start the class, I think a lot of you would have been really scared right away. Because they look long and big, and they use 2 Greek letters. We used A and B. When we did ours, we used capital A and capital B. They used the Greek letters alpha and beta. So they would seem like very scary formulas. But hopefully that activity, say, can tell you, hey, that's not so bad. This is what's happening. Mr. LaFrance. And these formulas are on our formula sheet as well. And there's also one, oops, did I miss it? I'm trying to find, no, not in that one. All right, well, I can't find it. It's in your notes on the next page. There's also the formula, oh, it's after example 1. So here it is. There's also the formula, here we go, for tan. Now, we didn't do an activity for tan, but that's on your formula sheet as well, the tan alpha plus beta formula. And with all of these formulas, these ones, you know, the other formulas up till now, I said you needed to have like 90–95% memorized. These ones you only need to have about 70–75% memorized, okay? Basically, you have to know that if I have a crap load of tans on one side, maybe it's my tan alpha plus beta formula. If I have like 4 things with sine and cos, I should check one of my sum and difference identities because it might be the other side. So we're actually going to start, we're going to do things in a little bit different order. We're going to skip example 1 for now. We're going to do example 2 to start with. And example 2 is just that. What we have to do with our identities, especially the sum and difference identities, and later our double angle identities, is be able to recognize when we have one side or the other. And so in A, I've got sine, cos, cosine. I've got a lot of things happening here. I've got 4 different trig functions. And so that should trigger me to say, in my alpha plus beta and alpha minus beta formulas, I have 4 things. So above this, I think, well, if this is alpha and this is beta, and this is alpha and this is beta, do I have a formula where on the right-hand side I have sine alpha cos beta minus cos alpha sine beta? So I look at all 4 of them. Sine cos minus cosine, that's the very first one on the list up there. Sine alpha minus beta. So what I do is I sort of say it's going to equal sine alpha is 8x, beta is 3x, and so if I simplify it, it'll just become sine of 5x. So that's in a simpler form because we take all of that stuff on the right-hand side and we change it to the left-hand side. Now in B, here we're looking, we've got 2 different angles. We've got a crap load of tans, so that might tell us maybe I should check one of my tan formulas. And I've got alpha, beta, alpha, beta. And so I want to see, do I have a formula where on the right-hand side I have tan alpha plus tan beta, 1 minus tan alpha tan beta? Is there one that matches up perfectly with that? Yes, the second one, tan alpha plus beta. So that means this whole thing is equal to tan alpha plus beta, so that would be pi over 6 plus pi over 12. How do I add fractions? I need to get a common denominator. Pi over 6 is 2 pi over 12. 2 pi over 12 plus 1 pi over 12 will be 3 pi over 12. Is 3 pi over 12 on your pi plate? It is. Why? Doesn't look like it should be. Yeah, because it's reduced that. So yes, in grade 12 you don't have to reduce fractions, but in sometimes if we do reduce them, we're like, oh, it is something on my pi plate. and tan of pi over 4 is equal to 1. So this whole thing of messy stuff to begin with is just equal to 1. And we'll do questions 4 and 5 for practice. We will do example 3 as well, so we'll do that right away.